The work done by F on the particle is 60 joules. Okay. They want us to find the work done by F. We have 10 times the distance, force times the distance, which is 6, equals 60 joules. That's the work done by F. See, they put kilogram just to confuse you, to think it has something to do with the mass, but it doesn't. They just want you to find force times distance, which is the work. Now for question 23. Okay, yeah, I got this wrong because it's a bit tricky. It's not that it's hard, it's like really easy. It's just you have to make sure you know, like you have to convert correctly. You have to remember what the rule was, because I converted the gram to kilogram and then immediately multiplied it by the distance. I forgot to make it into a force. So let's put this rule to remind us. Work equals force times distance. Alright? Now, for the first one, the work done by a man lifting a 200 gram object through 2 meters. We have distance, it's correct. So times 2. Now we need mass. You're gonna say we have it already. No, remember, it needs to be in kilogram. So 200 gram divided by 1000 equals 0.2 kilogram. Okay, when you have gram and you want to turn it to kilogram, just divide it by 1000. Okay, so you have 0.2. Remember, you don't put it immediately, it's mass. So you have to get force. Force is equal to mass times g, or weight equals mass times g. So the mass, 0.2 times gravitational acceleration, 10. 0.2 times 10 is 2. So 2 times 2 is 4 joules. And indeed it is 4 joules. Now, for B, the work done by a man lifting a 1 kilogram box through 20 centimeters is, okay, we have mass, okay, we need to turn it into force, so 1 times 10 is 10, that's the force, 10 newtons, times 20 centimeters. We can't put this, you're gonna say why? Because it needs to be in meters. Remember, when you do force times distance, force has to be in newtons, of course, and to get newtons, the mass has to be kilogram, and distance, it has to be in meters, okay? Now, we're gonna convert 20 centimeter to meters. So how will we do that? We just multiply, divide by 100. So 20 divided by 100 is equal to 0.2. So 0.2. 10 newtons times 0.2 meters equals to 2 joules. And indeed it is 2 joules. Now for the third one. The work done by a man lifting a 4 gram object through 20 meters is what joules? Okay. Again, it needs to be in kilogram. So we divide it by 1000. It's going to be 0.04 times 10 equals 0.04. Okay? Now that we have the force, newtons, we need to multiply it by distance, which we already have as meters, 20 meters. So it's going to be 0.8, because the 0 moves the decimal forward. So it becomes 0.4 times 2. 0.4 times 2 is obviously 0.8. Okay? That's it for the third one. Indeed, it is 0.8. Now for the last one. The work done by a 90 kilogram man moving through a distance of 3 meters is what? They're so kind here. This is a nice one. They gave us the mass immediately, so you can multiply it by the gravitational acceleration times the distance 3 meters. You get 900 times 3 equals 2700. And indeed, it's 2700 joules. That's the work. Now, consider an isolated system consisting of 3 interacting bodies, A, B, and C. Through these interactions, energy is transferred from one body to another. Which expression is true? Okay. So what happens here in an isolated system? You got A ball, B ball, and C ball. Okay. Now you're transferring energy between each one of them. Again, some of them one loses, some of them gains. Right? Energy lost by A, let's say, is 50. Energy gained lost by B is 50. Energy lost by C 50. Sorry. So yeah, you add them all up. This is. Wait 1 minute. I did something wrong. Hey guys, forget this. 1 minute. No, I don't know the whole diagram. Okay. So what's happening here? It follows the same logic if there was only two objects. Okay. The energy lost by A, energy lost by B, energy lost by C. They are all equal to 0. Okay. So same thing. If it was all gained, they're all equal to 0. That's it. It follows the same logic as the other ones, which was only two objects, A and B. Okay. That's it. Two bodies, P and Q, form an isolated system after interaction with Q. The energy gained by body P is 50 joules. Choose the correct answer to complete the sentences below. Okay, since body P gained 50 from Q, energy gained by Q is negative 50 since it lost 50, right? So what it gained is negative 50. Alright, so now for the second part, the net change in the energy of the system of bodies P and Q is 0. Since positive 50 and negative 50, add them to each other, it's 0. Okay? A toy car is projected across a rough floor. As a result, the kinetic energy of the toy car is halved over distance. Okay. We're gonna do work equals delta kinetic energy. But this question, they're really kind. What's happening here? They already gave us the entire initial kinetic energy. So we can, and they already told us what happens to the kinetic energy over time. It's halved over the distance. Okay? So that means the initial, which is 4, is halved over distance, and the final is the half of the initial. So that means the final kinetic energy is 2 minus the initial kinetic energy, which is 4. So it's going to be negative 2. Alright? That's the change in kinetic energy. But remember, work, it's still equal to work. So work equals 2 minus 4, work equals to negative 2. So we can say the work done by friction of the car is negative 2. Okay? Now remember, work is force times distance. We have force. Now we don't have force. We're trying to find force. We're gonna label it as F times 5, the distance, equals negative 2. It becomes, let me just erase all of this. Becomes 5F equals negative 2. Divide by 5, F equals negative 2 over 5, or 0.4, negative 0.4. But since we're asking for friction, we remove the negative since friction is already negative, right? It's like friction is like this, okay? And they're asking for this. We got this as the negative 0.4. So when we apply it, when we like substitute it for friction, it looks like this. So negative and negative becomes positive, 0.4. Okay? That's how it goes. Now, question 27. A body of mass 1 kilogram is pulled along a rough horizontal floor with a string parallel to the floor. The tension in the string is 3 Newton. As a result, the body moves through 6 meters and the speed of the body increases from 2 meters per second to 4 meters per second. Okay. Now, the change in the kinetic energy of the body is 6. Okay. How do you find 6? How do you find the change in the kinetic energy? What does change kinetic energy stand for? Let's do the work energy theorem. Delta kinetic energy, right? This is the change in kinetic energy. That's what they're asking for here. So we do the rule. 1 over 2 mv squared minus 1 over 2 mu squared. 1 over 2 times mass 1 times v squared. Speed of the body increases from 2. Okay. This is the final, this is the initial. So v squared, which is 4 squared, minus 1 over 2 times 1 times 2 squared, the initial velocity. You get here 16 times half, which is 8, minus 4 times 1, becomes 4. 4 times half is 2. So 8 minus 2 is 6. So the delta kinetic energy is just 6. The work equals 6. This is the delta kinetic energy, so it's 6 joules. Now, the work done by friction on the body is what? Negative 12. How do we do this? We're trying to find the work of friction, right? We already have the total work minus the work of tension, okay? So the work of friction equals the total work, which is 6. We already found it here. 6 minus work of tension. What's work? Force times distance. Force of tension is 3 times distance is 6. 3 times 6 is equal to 6 minus 18. 6 minus 18 is negative 12. And I need it in negative 12 joules. Okay. Now, let's remove this. The magnitude of the force of friction is 2 newtons. Okay, now that we already have the work of friction, negative 12, we're trying to find the force of friction, which is F. We're going to label it as F, times the distance, 6 meters. So we just solved for this. 6F equals negative 12. Divide by 6, divide by 6. Force equals to negative 2. But again, they're asking for friction, right? So friction is like this, negative friction. Friction is always negative. So when they're asking for the friction only, remove the negative sign, it's on its own. So when we substitute negative 2 for friction, it's going to be like this, negative, negative 2. Multiply that together, it becomes positive 2. Basically, they're asking for friction. If you put negative 2, it's basically defying it, because you're saying friction is not negative. Friction is already negative. We don't need to put the sign. We already know it's negative because it's friction. So we only put the number as if the sign is already there, okay? Like in math, when they ask you to put in an equation, they already put a minus. So you don't put in the square minus x minus 2. No, you put only 2 because they already put the negative for you. Okay, same thing here. Alright, that's it for this question. Oh, sorry. Now, for question 28. A small ball of mass 0.20 kilogram is projected at 10 meters per second, parallel to the ground at a height of 8 meters. The only force acting on the ball is the force of gravity. Okay, like I said, at a height we use mgh. We have g as, we have mass 0.20. We do use mgh, right? Times 10 times h, 8. You get 10 times 0.2, which is 2. 2 times 18 is 16. So the work done by gravity on the ball by the time the ball hits the ground is 16 joules. They're asking for the work done by gravity. When they ask for work done by gravity, that means they're asking for mgh. So you do this, you get 16 joules. Now, for the second one, according to the work energy theorem, the kinetic energy of the ball as it is about to hit the ground is what? Okay. Before we solve, we need to do the third one first. Okay. The third one, we need to find the second one, we need the final velocity, which we don't have. We already have the initial one, which is 10 meters per second, right? So we need to find the final velocity before solving B. So, since we're only asking for the final, not the initial, which we already have, we'll do only 1 over 2 mv squared, which is 1 over 2 times 0.2, the mass, 0.20, times the velocity squared, what we're trying to find, equals, what's it called? Yeah, equals 16, the work. Okay? So you're gonna do 1 over 2 times 0.2, you get 0.1 times velocity squared, v squared, equals 16. 16 divided by 0.1, you get 160. So v squared equals 160. Make it radical form. You get v equals, what? Wait, sorry guys. Okay guys, so I fixed my mistake. My bad. I really forgot to do one important step. Okay. So again, we use the rule work equals delta kinetic energy. Okay, let's start anew. Work, we've got 0.20 kilogram. We need to make it to force. So 0.20 times 10 is 2. Times distance, which is 8 meters. Equals 1 over 2 times mass 0.2 times v squared. This is what we're trying to find in the third one, right? Minus 1 over 2 times 0.2 times 10 squared, the initial velocity, right? Now let's solve. 16, 2 times 8 becomes 16. Now half of 0.2 is 0.1, 0.1 times v squared is 0.1 v squared minus half of 0.2 is 0.1, and 0.1 times 10 squared is basically 0.1 times 100 is 10. So minus 10. Okay. Now let's move negative 10 to the other side. It becomes 0.1 v squared equals 10 plus 16, which is 26. Divide by 0.1. Divide by 0.1. Get, make it in the calculator. So 26 divided by 0.1. You get v squared equals 260. Now make it, you have to radicalize both of them. You get v equals, put it on the calculator, radical 260 is 16.125, which is basically 16. So the final velocity is 16, and indeed it is 16. Now we can find the second one, the kinetic energy of the ball added to the ball to hit the ground, which is the final kinetic energy. So let's start again. 1 over 2 times mass 0.2 times velocity squared, velocity final squared. We already found the velocity final, which is 16 squared. Now put it on the calculator. Half of 0.2 is 0.1 times 16 squared. You get 25.6, and you round it up to 26 joules. And that is what we got here. Hope you guys understood. Let me just recap quickly. Here, work done by gravity on the ball, you do mgh. 0.2 times 10 times 8. You get 16. Okay? That's for this. And that's all for the first one. Second one, you find the final kinetic energy. But before we can do that, we need to find the final velocity, which is what they're asking for in the third one, in C. So, what do we do in C? We do work equals delta kinetic energy. Work is force times distance. We have 0.2 kilogram times gravitational acceleration 10. You do 0.2 times 10 is 2 times distance 8 equals 1 over 2 times mass 0.2 times v squared, what we're trying to find, minus 1 over 2 times 0.2 times 10 squared. Okay, you're gonna solve for this. You're gonna get v squared equals 260, and then you're gonna radicalize both of them. You're gonna get v equals 16. So you have the final velocity. Now for the last one, second one I mean, to find the final velocity, final kinetic energy, we just do 1 over 2 times 0.2 times 16, the final velocity squared. You multiply all of them, you get 25.6, which we rounded to 26. Okay, so that's it for this question. Okay, so now for this one, a block of mass 3 kg is descending from the top to the bottom of a rough inclined plane at a constant speed of 1 meter per second. The angle of elevation, they gave us the angle, of the plane is 30 degrees, and the length of the plane is 5 meters. Use gravitational acceleration equals 10 meter per second squared. Okay, this is very easy. The total work done by normal reaction on the block. They want the total work here. Okay, should be simple. Okay, by normal reaction. Now let's see the block. Here's the block, right? It used to be here. Like we said, weight, the forces acting on it is what's it called? Let me rough. So friction is here. Friction is like this. Normal is perpendicular to the plane, so it's like this. This is normal, and the weight is always vertically downwards. Okay, which is gravity, weight or gravity. Okay, so normal when it's perpendicular, it's always 0. Okay, since it's perpendicular, it's always 0 joules. Okay, so when you see normal on a plane, you know it's 0 because it's perpendicular. Now, for the second one, the total work done by gravity on the block is 75 joules. How do we find this? We need to, of course, use the rule of work. Force times distance. So we do force, we find force 3 kilogram times 10, which is 30, times distance, times distance 5 meters, equals, before that, we can't, that's not the answer. We need to multiply it again by sine 30. Why? Let me explain properly. They're asking for gravity, right? The total work done by gravity on the block. Correct? They're asking for total work done by gravity. Okay, so you do 30, since it's, what's called? They're asking for gravity, which is vertically downwards. Sorry, it looks autistic. Vertically downwards. Okay, when it's vertically downwards, which is this is what we're trying to find basically. Okay, it's basically going to be what's it called, sine, right? Like I said in the previous questions, horizontal is cosine and vertical is sine. So we have the angle over here. Imagine it like this. We have the angle, right? You might think it, oh, we need horizontal. No, that's not what they're asking for. Remember, they're asking for gravity, which is vertically downwards. They're not asking for this side like they did in the previous question. No, they're asking for the one going vertically downwards, the gravity, the weight. So you use sine 30. Do not use cosine. Cosine is for horizontal only. It's strictly horizontal. But sine is for vertical. Some may say sine and cosine, when you multiply them, sometimes you get the same answer. But no, that may not always be the case. Sometimes you get different answers. So you have to be really careful to know which one to use. Vertical, sine, horizontal, cosine. Memorize this. Know this, okay? And you can always check the triangle the mathematical way if you want. But that's unnecessary. So you do 30 times 5. Let's look on the calculator. 30 times 5 times sine 30 is going to be exactly 75. And indeed, it was 75 joules. Now for the last one, they're asking the total work done by friction on the block. Friction is basically just negative. Friction is negative, right? So it's a negative of what we got here. That's it. So remember, the work we got for gravity 75. Friction is just negative. It's opposing it, so that's why it's negative 75. Okay, that's it. Now we reach to the easy questions. For each example, state whether the interaction described occurs with or without energy transfer. Drag and drop. A book is resting on a table. Now imagine this. On a table, you got a book, right? Is there anything happening? Is there anything going on? Is there any energy transfer? Any forces? Yeah, there are forces. I mean like energy, sorry, not forces. Any energies entering or leaving, gaining or losing? Is it? No. It's just resting on the table. Nothing is happening. So there is no transfer. A bucket is lifted upward at constant speed. So imagine a bucket used for, let's say, from a well, let's say, okay? Used for drinking. They pull it up constantly at a constant speed. It's going up. So there's, even as though it's might be at a slow speed, there's still energy transfer. So yes, there is energy transferred. Since it's going up, so the potential energy is increasing. Or yeah, that's basically it. And now for the third one, a rock travels uniformly through open space. Space. I'm sure all of you guys know the rules of space from movies by now. Let's say an asteroid, okay? It's traveling through space. Space, there are no forces, no gravity, nothing, okay? There's nothing going on. So it's just traveling uniformly at a constant uniform matter. So there's no energy to transfer. It's not losing or gaining or anything. Nothing's happening. It's in space. So yes, there is no energy transfer. That's why what's it called? When you see in movies, when the asteroid suddenly enters Earth's atmosphere, it suddenly gains heat. That's from friction, and that's basically energy transfer. It starts getting sucked in from the Earth's gravity, Earth's gravitational field. Okay. So that's why it changes suddenly. It's not on fire in space, right? It's not increasing speed in space. No, it's moving uniformly. That's it. A ball is in a free fall. Free fall is basically like dropping something from a certain height. It's in a free fall, basically meaning it's on Earth. So there is forces acting on it, and it's losing or gaining energy. At this case, it's losing potential energy as it goes down and gaining kinetic energy. So there is energy transferred in the end. Okay, that's it. A person is pulling a box along a rough floor using a rope parallel to the ground. The tension in the rope is 25 newtons, and the box moves through 2 meters at constant speed. The work done by the frictional forces on the box is what is gonna do this. It's so easy. Tension, right? Let's imagine this. A person is pulling a box using a rope parallel to the ground, a rough floor. Remember? So there's friction. The tension in the rope is 25 newtons, and the box moves through 2 meters at constant speed. So friction is this way, and direction of motion is this way. So what does this look like? Resistive work. So it's negative. So you do tension 25 times 2 equals 50. It's resistive, so it's going to be negative. That's it. Question 32. A block of mass 2 kilogram initially moving at 10 meters per second is subject to a force of 3 newtons directed opposite to the displacement. When the block is displaced by 5 meters, its speed given to the nearest integer becomes 9 meters per second. So let's solve this. Okay, they want us to find the speed, okay, which is basically the final velocity. So we're gonna use work equals delta kinetic energy. Work, we need to find force. 2 times wait, sorry, here's the force, we already have it. 3 times force times distance. 3 times 10, sorry, not 10, 5. 3 times 5, that's work, equals oh, by the way, it's subject to a force of 3 newtons directed opposite to the displacement. So that means it's resistive, so it's negative. Okay, equals delta kinetic energy, 1 over 2 times mass 2 times velocity squared. What we're trying to find is final velocity, so v squared, minus 1 over 2 times 2 times 10 squared. It's initially moving at 10 meters per second squared. Meter per second, sorry. So now, let's multiply. Negative 15 equals 1 over 2 times 2 is 1, v squared, minus 1 over 2 times 2 is 1, 1 times 10 squared is 100. So, you move the negative 100 to the other side, you get v squared. Let me just erase, it's getting messy. You get what? Okay. You get v squared equals 100 minus 15. So it's v squared equals 85. Radicalize. You get v equals, put radical 85 on your calculator. You get 9.21. But they want us to the nearest integer, so you just round it up to 9. So it's 9. That's the answer. So now for question 33. A box of mass 15 kg is lowered through 2.50 meters. Using gravitational acceleration 10 meters per second squared, the work done by gravity is what? Okay, it's being lowered, right? Remember when I say at height, you use mgh here. So 15 times 10 gravitational acceleration times 250 the height. You get 15 times 10 times 2.50, put it on the calculator, or you can solve it manually, whatever you like. You get 375 joules. That's the work done by gravity. Always, when you see work done by gravity, you know it's mgh. That's it. Because it's acting potential energy. It's on a certain height. So it's logic. Now for the final question. For each interaction, state whether the work done by the acting force is motive or resistive. Drag and drop the correct terms from the box below. Weight of the box as it slides down an inclined plane. Okay, let me just quickly illustrate what's going on. So look, imagine a hill, okay? Imagine a hill, okay? Now, I'm sure you've seen in cartoons when the character has a bike, okay? And attempts to go up the hill, uphill. Or not only in cartoons, you will physically do it in real life. You try to go up a slightly sloped hill, okay? It's really hard, it's difficult. You put a lot of work in it, you lose a lot of energy. You put a lot of energy and effort into trying to go up until you reach this point, okay? Now, when you reach this point, you suddenly go down, okay? Now when you go down really fast, okay? So why does this happen? It's usually because of forces and gravity. It's easier to go down than go up, okay? So yeah, you go down. So that's you go down at a really fast speed, especially if you're on a bike, to the point you can't even stop the bike until you're at a slightly leveled ground. So let's illustrate it to the question we have. Weight of the box as it slides down an inclined plane. It slides down an inclined plane. Motive, the weight, okay? It slides down, like I said, it's motive. It goes with the direction of motion, with the force. There's nothing resisting it. So that's why it's motive, it's positive. Weight of the box as it is pulled up an inclined plane. Let's say pulled up. It's going to be resistive because the force of weight is down while the direction of motion is up. 1 minute, it's getting confusing. Weight is down, direction of motion is up. That's why. So yeah, weight is down, direction of motion is up. That's why it gets a bit difficult, okay, to go up, because it's resistive while going down. It's motive. That applies to life too. It's easier to go down than go up. You gotta put a lot of effort into rising and becoming better. Anyways, so you're gonna erase everything. You're gonna put friction on the box as it slides down an inclined plane. Okay, and over here also, friction on the box as it's pulled up an inclined plane. Now, it's saying friction, basically resisting it. So in all cases, whether it's going up or going down, it's resisting, because there is friction. So like, imagine the hill, okay? Even if it's, imagine the hill, okay? Even if it's going down, this is a bit rough. So it's going to be hard to put it down, you know what I mean? Like imagine Putting a box down stairs is really hard, right? But pushing a box down a slide is really easy because of friction. Stairs is rugged like this, so the box is going to have a hard time going down smoothly, unless you throw it, of course, but that's a different topic. But in a slide, let's say, you put the box and you immediately go down. It goes down really quickly. This is because of friction. So whether or not it's going down, going up, there's friction, it changes, it becomes resistive, okay? Because friction is a resistive force. So in all cases, it resists it. So that's why it loses energy. Alright? So yeah, that's it, guys. Hope you understood, and I hope this helps. I know I spent a lot of time explaining this quiz, but why not? It's nice to understand the topic, to properly understand the material. Because if you understand it, you won't ever need help in it again. You know what I mean? Like if you memorize it now, you'll forget after a while. Maybe you'll know it tomorrow, but you'll forget it after a while, and you have to repeat the same cycle. But if you understand what's going on, you won't even need to watch this video again. You only have to watch it once, and you know what's going on. Okay, that's the beauty of physics. Understanding is better than memorizing. Alright? Anyways, I'll see you guys and wish you the best of luck on your exams. Okay? See you guys.